This is Mrs. Appia with Lesson 15, Random Sampling. Student outcomes for this lesson. Students select a random sample from a population. Students begin to develop an understanding of sampling variability. Pause the video and copy the essential question. Name a few ways the sample statistics might vary when several different samples are taken from a population. In this lesson, you will investigate taking random samples and how random samples from the sample population vary. In our first set of exercising, sample pennies, do you think different random samples from the same population will be fairly similar? Explain your reasoning. Most of the samples will probably be about the same, because they come from the same distribution of pennies in the jar. They are random samples, so we expect them to be representative of the population. Below is a dot plot of the pennies' ages. The plot shows the number of years since being minted, which is the penny's age, for 150 pennies that JJ collected over the past year. Describe the shape, center, and spread of the distribution. The distribution is skewed. Many pennies minted fairly recently. So notice on the left side of the dot plot. Notice that there are a lot of pennies over in this section, and these are the newer pennies. You determine a penny's age by subtracting the date from 2017. So all of these dots represent brand new pennies. They are 0 years old. Then this number over here looks like it would be about, let's see, this is 40, 48, probably about 6 more, maybe 54 years old. So the date on that one would be 2017 minus 54. So we want to describe the shape, center, and spread of the distribution. The shape is that it is skewed, and notice that we have a lot of the data over on the left side. So we have more pennies that are newer than older. The minimum is 0. This is the minimum, 0 years old. The maximum is 54 years old, since the penny was minted. Since the data is skewed to the right, I would expect the mean, or the average, to be below the median, the middle number of years, around 18 years. So think, how do you determine a median in a line plot? Remember to count the data points and then divide it exactly in half. So we would count the data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. We know that there are 150 pennies, so exactly half would be the 75th dot. And so you just keep counting until you get to the 75th dot. And here it would be about 18 years. And that is our median. Things you want to pay attention to on the line plot are the minimum, or the lowest number, the median, and the maximum, as well as if the data is skewed or not. Place 10 dots on the number line that you think might be the distribution of a sample of 10 pennies from the jar. So you are actually going to make these numbers up based on the line plot. Okay, one of the things that I notice is that there are a lot of newer pennies. So I'm going to put several of my pennies as younger or newer. 1, 2, and then the oldest penny was around between 48 and 50 years old. So I'm going to put a penny over there as well. Then I have some pennies in the middle. So let's see, we've got 3 so far. 4, 5, 6. And then I have more pennies on the lower end. So I'm going to put more over here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So notice that my data looks similar to the line plot. Next, select a random sample of 10 pennies and make a dot plot of the ages. Describe the distribution of the penny ages in your sample. How does it compare to the population distribution? So I have 100 pennies or 150 pennies, and I'm randomly selecting 10 pennies with replacement. So I draw my first penny, and my first penny is 1979. Subtract that from 2017 to see how old the penny is. It is 38 years old, so I put my dot at 38. Replace the penny and draw another. Then we had another at 0, another at 2, one at 5, one at 10, one at 12, one at 18, two at 38, and we have a 52 and a 58. Those are my 10 randomly selected pennies. Now describe the distribution of the penny ages in your sample. The distribution. Notice that it is skewed to the right again. More newer pennies than old. And notice that it is similar to the data that was on the 150 penny line plot, where I have more data at the younger pennies versus the older pennies. Compare your sample distribution to the sample distributions on the board. So what I did is I collected data from 5 students, and these were the results. Sample 1, sample 2, and what I want to do when I compare the data is I want to take a look at the median, the lowest number, the highest number, and the general distribution. So I'm going to highlight the lowest number in each group in yellow, and the highest number in each group in green. And then I'll do the median in pink. So to find the median, there are 10 pennies here, so I need the middle penny. So here we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the median will be between these two dots, halfway in between it. So our median is about here. For sample 2, I'm going to go through the same procedure. I've got the lowest number and the highest number, and then the median. The median here is at about 10. Then I repeat the procedure. The lowest number, the highest number, and the median. One more time to do the median together. I've got 1, 2, 3, 4, 5. So the median will be between these 2 points. And then I've got sample 4 and sample 5. Some of the things that I observe here. The samples are fairly different. Most have the same minimum of 0 years. The maximum years vary quite a bit, where we have a maximum of 55 for this group and then a maximum of about 35 for that group. That's quite a variance in the maximum. Also, look at the medians. Some of the medians are in the middle, but most of them are lower than half the age. But notice that the median is actually below most of those. Okay, so let's write down what we have noticed, what we have observed. The samples are fairly different. Most have the same minimum of 0 years. The maximums vary between 35 and 54 years. One median is in the middle, but most are below the middle. Pause the video and copy the observations. How does your sample distribution compare to those on the board? So your sample was back here. And the sample that we did is similar. We have some values at 0, some We have the same minimum as the others. The maximum on our sample was 45 years, which is pretty consistent with the others. And the mean is around 18 years, which is consistent with the others. In examples 6 through 9, grocery prices and rounding. Look over some of the grocery prices for this activity. Consider the following statistical questions. Do the store owners price the merchandise with cents that are closer to a higher dollar value or a lower dollar value? Describe a plan that might answer that question that does not involve working with all 100 items. So we have 6 items shown here along with their prices. But for our activity, we use a list of 100 items and all of their prices. So we want to describe a plan that might answer the question, but we don't want to use all 100 items. So how could we come up with which prices and items to use? The first thing that I would do is I would place all of the items in the bag. So we took our 100 items that are written on a piece of paper along with their prices. We cut them into 100 pieces and we put them in a bag. The prices in the bag represent the population. Then I would begin by selecting items from the bag and record the prices of each item I select. And every item has an equal chance of being selected, so it is a random sample. And I do this with replacement. So I draw the item out and then I write it down, but then I place it back in the bag. I would get a sample of at least 10 items out of the 100. Question 7. Do the store owners price the merchandise with cents that are closer to a higher dollar value or a lower dollar value? That's the question we want to answer. To investigate this question in one situation, you will look at some grocery prices in weekly flyers and advertising for local grocery stores. Question A. How would you round $3.49 and $4.99 to the nearest dollar? So when you're doing the rounding, you want to determine if the cents are enough to round up to the next dollar or down to the lower dollar. So $3.49, is it closer to $3 or is it closer to $4? $3.50 would be in the middle, and we have less than that. So if you have less than half, you round down. If you have exactly half or more, you round up. So $3.49 rounds to $3. And $4.99 is closer to $4 or $5. $4.99 is closer to $5. So $3.49, this one has been rounded down, and the price of $4.99 has been rounded up. Question B. If the advertised price was 3 for $4.35, how much would you expect to pay for one item? So let's say that you're buying 3 apples. 3 apples for $4.35. How do you figure out how much you pay for one item? Remember to take the total price and divide by the number of items. So we have $4.35 divided by 3 items. So go ahead and take your calculator or do the math and divide that. That answer is $1.45 each. Question C. Do you think more grocery prices will round up or round down? Explain your thinking. Go ahead and answer that question. This is an opinion question. I believe that prices are usually rounded up so that the store collects more money. Question 8. Follow your teacher's instructions to cut out the items and their prices from the weekly flyers and put them in a bag. Okay, we've already done that. Our bag is ready. Select a random sample of 25 items without replacement and record the items and their prices in the table below. So when we do our random sample, this one we're going to do without replacement, which means we take out the piece of paper, we write down the item, and then we don't put it back. So our first item is grapes, and I'm just going to abbreviate. The price of the grapes are $1.28 per pound. Then our next item is peaches. And these are $1.28 per pound as well. Our next item is melons. And the price is $1.69 per pound. Our next item is tomatoes, and they are $1.49 per pound. Next, we have shredded cheese. And a package is $1.88. I'm going to pause the video and write down all the prices. You should copy them into your book. Copy all of the items onto your table. Next, question 9. Round each of the prices in your sample to the nearest dollar and count the number of times you rounded up and down. So $1.28 would be rounded to $1, and then determine whether that's a round up or round down and write it down. Next, $1.28, round it to $1, and that would be rounded down. $1.69 is closer to $2, so we round it to $2, and that one has been rounded up. Pause the video and complete this activity. Next, count the number of times you've rounded up and down. So I'm going to count the times that I've rounded up. 1, 2, 3, 4. Pause the video and complete this activity. If you rounded and counted correctly, then you should have a total of 15 times rounded up. Let's write that with a pen. 15 times rounded up, and the percent of prices rounded up. Well, that's 15 out of 25. And 15 divided by 25 times 100, and that gives us 60%. So 60% of the prices have been rounded up. The number of times rounded down. Well, we had 25 items and 15 of them were rounded up. So the difference, keeping in mind that one of them was not rounded, that was 10, and then minus 1, which was not rounded, would be 9. So we had 9 items rounded down. Given the results of your sample, how would you answer the question? Are grocery prices in the weekly ads at the local grocery closer to the higher value or the lower value? So in our sample, we had 15 out of 25, and that was 60%. They were rounded to the higher value. Now, that's more than half were rounded to the higher value. So evidence seems to suggest that the more prices are set to round to a higher or lower, more than half would suggest a higher amount than to a lower amount. Pause the video and copy that down. Share your results with classmates who use the same flyer or ads. Looking at the results of several different samples, how would you answer the question in Part A? So I polled 32 students, and those samples were between 54% and 70% of the prices that were rounded to a higher value. And notice that these are also more than half of the prices were rounded up. Based on this finding, prices are typically set to round up, not down. Question C. Identify the population, sample, and sample statistic used to answer the statistical question. The population, remember that this is the large group from which the samples are taken. So the population is all of the prices from the flyer. The sample is the smaller selection of data from the population, and that would be the set of prices drawn from the bag. The sample statistic is the statistic determined using the sample. And this was the percent of prices that were rounded up. Question D. Bettina says that over half of the prices in the grocery store will round up. What would you say to her? She might be right. We only looked at the prices in the flyer, which doesn't include every price of every item in the store, so we don't know for sure. In this lesson, we have learned different random samples from the same population will result in different medians, maximums, and minimums, but should have some resemblance to the population. Also, to be a random sample, each different sample must have the same chance of being selected, which means every item has to have the same chance of being chosen.